Hey guys, so in this video, we are specifically going to be looking at equations with variable on both sides. So our solving process is exactly the same, all right? However, we're going to still be doing kind of that opposite operation. So I'm going to go ahead and find a piece of paper and cover up part of this. So we're going to go ahead and start our notes. So we're going to write solving with a variable on both sides and kind of just what I just said. The process of solving is exactly the same. All right, we're doing the opposite operation. So we've learned in the marriage chart, when I have addition, the opposite is subtraction. When I have multiplication, the opposite is division. When I have squared, it's square root, and cubed is cubed root. All right, so we're going to be kind of using that concept. The key difference here, though, is that I have to move that variable first. I'm going to have a variable on both sides of the teeter-totter. So because they are the same thing, I actually have to move them together to actually make the process work. I can't have apples on one side of the equation and apples on the other side of the equation and balance it out. So we have to get them all to that one side, combine them, and then solve. All right, so let's take a look at what this is going to look like. So again, if at any point you're looking at this and you're like, ooh, I need more time to write, pause, all right? Or if you're confused about something, you can always replay. All right, so we're going to take a look at this very first equation. So this says 5x minus 2 equals 3x plus 4. So we're going to go ahead and take a look at this equation. So let's analyze it first. So the first thing that you see is that we have 5x on the left and we have 3x on the right. You should also notice then there's a constant on each side. So we kind of have to play the game of variables to one side, constants to the other. All right, so the first thing is we're going to move the variable first. So one of the rules that we're going to kind of jot down to ourselves is we're going to move the larger first. Now understand with this is only if there is a variable on both sides. You're going to see here an example too where that situation kind of changes. Okay, so we take a look. Oh, I totally butchered that. I'm sorry. We're supposed to move the smaller. That would have been silly. Sorry, I got ahead of myself there. We're going to move the smaller variable first. So we're going to take a look. I have 5 x's on this left, and I have 3 x's on this right. So we have to ask ourselves, well, who's smaller? Well, in this case, 3 x's would be smaller. He is a positive 3x, so in order to move them, we're going to use the opposite operation. The opposite of positive is negative. So we're going to go ahead and we're going to subtract 3x from both sides. Notice I included the x with it, all right? I'm not just moving the 3, I'm moving 3x. It's the total package that's moving. Because I'm using subtraction, I'm going to go ahead and I'm going to draw my equal sign bar below it, and we have our mini equations. So 5x's minus 3x's make 2x's. I have a pen that wants to work here. I'm going to bring down this negative 2, bring down my equal sign. 3x's taking away 3x's is going to end up canceling, and I'm going to bring down my positive 4. All right. So we notice here that my variables have now claimed the left side. We also notice if I cover this up and I only look at that, we're now in a two-step equation. All right. So now we need to get rid of what's not touching the variable first. So I'm going to go ahead and say number 2, we are going to go ahead and solve the two-step. All right, so we're going to get rid of what's not touching first. So the opposite of negative 2 is positive 2. And what I do to one side, I'm going to go ahead and I'm going to do to the other. So I'm going to bring down that 2x. Negative 2 and positive 2 cancel. We're going to equal. So 4 plus 2 makes 6. Right? And then we're going to end this equation by dividing, because that is in fact multiplication. So we're going to divide both sides by 2. So we get that x equals 3, because 6 divided by 2 is in fact 3. Now I can check this by plugging it back into the equations. Let me reach for a pencil here. All right, so we would have 5 times 3 minus 2 equals 3 times 3 plus 4. Well, 5 times 3 is 15 minus 2 equals 9 plus 4. 15 minus 2 is 13. 9 plus 4 is 13. Those two sides balance out. So that's how I know I got my answer correct. All right. So again, we move the smaller variable first, and then we solve the two-step equation. All right, let's take a look at another example. So this is another format in which a problem can be given to me. All right, and this, for whatever reason, is the one that actually throws us off because we're so used to seeing things balance this. Sorry about that. So we're now going to kind of take a look at the situation. So if you notice, I have a variable on both sides, but I only have one constant. So this would kind of be like looking at going into a lunchroom. All right, and one friend is sitting at the lunch table together. We have two people sitting at a different table, but the K's are friends. Well, it wouldn't make sense for the 15 to come to this other side and then kick the 7K out. It doesn't make sense. The K has already claimed its side. It's already saying, hey, I'm good. I'm going to stay over here on the left. And he's basically calling his friend over and he's saying, hey, you come over here to me. All right, so this first concept of moving the smaller variable first won't actually work in this instance. Now, for this one, it's perfect. However, we kind of need to know, in this case, we're just going to take the variable and we're going to automatically kick him to this other side because the 7K has already claimed it. All right, so right off the bat, we're going to say what's opposite of negative or positive 4K, and that is negative. All right, so we're going to say minus 4K on both sides. What I do to one side, I'm doing to the other, and then we're going to have our equal sign bar. 7 minus 4, that would make our 3Ks. We have our equal sign. 4 minus 4 cancels out, leaving us just then this 15. All right? So the variable has already picked one side and the constant's on the other, so we're going to go ahead and finish solving this. So the opposite of multiplication is division, so we're going to divide by 3 on both sides. So we're going to get that K equals 5. All right, so again, to check this answer, we're going to take this 5 and we're going to plug it in. So we get 7 times 5 equals 4 times 5 plus 15. Well, 7 times 5 is, in fact, 35. 4 times 5 is 20 plus 15. 35 equals 35. Check. We're balanced. All right. So I'm going to go ahead and I'm going to give you 2 problems to try yourself. All right. You're going to go ahead and you're going to pause the video if needed once you have these written down. And you're going to go ahead and record your answers into me. So we have 4b plus 2 equals 3b. And we have 5 plus 3y equals 7y minus 3. So we're going to go ahead and we're going to try these. So go ahead and pause the video so you can go ahead and work on these assignments. All right, so now that you have recorded your answers, let's see if you're right. All right, so let's take a look. So this first one, 3b has already claimed its side. So we're going to go ahead and we're going to subtract 4b from both sides. All right, so that leaves us with 2 equals a negative b. And just like in our other instance, this negative has to go away, so we're going to put him onto the other side. So b would have equaled 2. Now, if you would have solved this moving the other direction, so I'm going to show that real quick. So 4b plus 2 equals 3b. If you would have moved this 3b first because you said he was the smallest, you're going to say minus 3b from both sides. And that leaves b plus 2 equals 0. You cannot just magic math this equal sign, okay? So understand everything is vertical. So then in this case, we would have subtracted 2 from both sides, so b would have equaled negative 2. All right, you're going to get, you're going to get that same answer regardless. I forgot I moved the negative, but I didn't write it. Just keep in mind you have to have that 0 placeholder if you solved it this other direction. All right, let's go ahead through this one. The smaller of the variables is 3y. So we're going to subtract 3y from both sides. I certainly could have subtracted 7y and worked with a negative 4. That was entirely your choice. But I would always recommend moving that smaller one so that way you're always working with a positive if possible. All right, we're now going to add 3 to both sides to balance this out. So we get 8 equals 4y. Then we divide both sides by 4. So we get y equaled 2. So let's see, wonder if you got -2 and +2. All right, so that's variable on both sides. Kind of straightforward, move the variable over, solve the two-step equation. Well, as we learned in the other, there's kind of multi-step as well that you can be taking a look at. All right, so multi-step equations have variable on both sides, except we have either combining like terms or distributive property also embedded within it. All right, so taking a look here, all right, I have variable on both sides. Right? And then I also have the instance of a set of parentheses. So I have to get rid of those parentheses first in order for me to accurately do this. So I'm going to go ahead and remember to do the distributive property. We are going to rainbow. So we're going to do 2 times y gets us 2y. We have 2 times a +6. So remember, every time we do this, that's multiplication. So 2 times 6, that's a +12. And then we bring down our equal sign of 3y. So now we analyze, is there anything to combine? Are there any more parentheses? No. So now we go into solving. All right, y has already claimed this right side, so I have to move this left one into its side. So we're going to go ahead. We're going to do the opposite by subtracting. This is addition. We're going to subtract. And what I do to one side, I'm going to go ahead and I'm going to do to the other. 2 minus 2 cancels. This +12 is going to come on down. And then we have 3 minus 2 makes just a y, and there's nothing else to do. Y equals 12. Now, a lot of times people like to put that 1 there. You're not wrong if you do. That's fine. Just there's no need to multiply or divide by 1 because 1y is y. So you're going to want to make sure your answer is declared then that y equals 12. And then obviously I can plug this in. 12 plus 6 is 18. 18 times 2 is 32. And then or 36. And then I can plug in 12 times 3 is 36. 36 equals 36. All right, let's try one more together, and then you'll be released to do a couple problems yourself. All right, so in this example, all right, we have a bunch of numbers. A lot of times whenever I show this on the smartboard, we all get the, whoa. Okay, so let's read it out. So example 4, you're writing this down. We have 3 minus 5b plus 2b equals -2 minus 2 times the quantity. So notice I said times 1 minus b closed quantity. All right, and I'm going to actually go ahead and I'm going to put my little fence guy because I want you to see there's 2 halves to this. And when you're solving stuff like this that it's overwhelming, I encourage you to kind of cover up certain sides. So I'm going to cover up this right so we can just focus on the left side of the fence. So we have 3 minus 5b plus 2b. So right off the bat, as soon as I say that, you can hear that I said b twice, which means we're going to be combining those together. All right, so I'm going to go ahead and I'm going to give myself a little circle so I can see. And remember, the sign is included with it. So we have -5 plus 2. Now, if you need to use your calculator, please do so. If integers are still wonky and you're like, I don't know how many that is. Well, keep in mind, the signs are different. So we take the sign of the larger number, we go toward subtract. All right, so we're going to see here the negative is bigger, and he's bigger by 3, 5 minus 2. So we have -3b's, and I'm going to bring down this 3 because he wasn't used. So this left side turns into 3 minus 3b. There's nothing else, no more parentheses, nothing that goes with it. So we're going to go ahead and we're going to uncover and go to this other side. All right, so here we have -2, we have -2, and then we have a quantity, which means I have to distribute. I have to get rid of that set of parentheses. So we're going to go ahead and we're going to distribute that -2 to both spots. All right, so this -2 is going to come on down. -2 times 1 is in fact -2. -2 times -b. Well, 2 times b is 2b. Negative and negative would make this positive. So now when I read it out loud, it says -2 minus 2 plus 2b. Well, notice again, when I said that, I said -2 minus 2. I can do that math. -2 minus 2 more would make -4. Again, if you are not good with your integers and need to use your calculator, do so. Signs are the same. Keep the sign, add them together. And then this 2b doesn't get combined with anything else, so we're going to bring him right on down. All right, there's nothing else to combine or distribute, so I'm done, and I now have my equation. I have 3 minus 3b equals -4 plus 2b. And now I'm going to solve. Which one is smaller, negative or positive of my b's? Well, that negative is smaller. Although it's a 3, negative is smaller. It's worse to have no money than it is to have some money. So I'm going to go ahead and I'm going to add 3b to both sides. I'm going to draw my equal sign bar, and now I can kind of condense things together. We have 3, so I just brought him down. -3 and +3, well, those cancel. We're going to bring down our equal sign. We're going to bring down our -4 because he wasn't used yet. And then 2b and 3b makes 5b's. All right, from here then, I'm going to go ahead and I'm going to move this -4 because he's what's not touching the b. And I'm going to say +4. And what I do to one side, I'm going to go ahead and I'm going to do to the other. Equal sign bar because I'm adding. 3 plus 4 makes 7. I cancel the -4 and the +4, which gives me 5b. Okay, so then from here, I'm going to go ahead and I'm going to divide because that is addition. All right, and I'm going to go ahead and put in there that answer. All right, and then here's what usually happens. You guys pick up your calculator and you're like, 7 divided by 5 equals, and you get 1.2. And that's great, but your answer is actually already there. If you notice, you have an improper fraction. You can write that as your answer. You can record that your answer is b equals 7/5. If your answer is recorded as a fraction, leave it as a fraction. Unless you have decimals in that original, please, please, please do not write the decimal answer. So in this case, 5 goes into 7 one time, leaving 2/5 remaining. So I'm sorry, it should have been 1.4. All right, please don't write 1.4. Please leave it as a fraction. All right, only write it as a decimal if the decimal is listed in the answer. All right, now you might look at that and you're like, I got a fraction. Fractions make us nervous. So if you need to check your answer and you need to please plug it in there, do it. Okay, if you need to double check that when you simplified, you got those answers correct, do it. All right, there is no hard feelings on rewriting this and saying 3 minus 5 times 7/5 plus 2 times 7/5 equals -2 minus 2 times the quantity of 1 minus b. Because you know what? You could be right, you could be wrong. So let's check this. I'm going to grab a handy dandy calculator because I can, and I also want you guys to see how you can use your calculator. All right, I'm going to type this strand in. I'm going to type in 3 minus 5 parenthesis 7 ABC 5 close parenthesis plus 2 parenthesis 7 ABC 5 close parenthesis. So I got on this left side -1 and 1/5. So let's see what we get on this other side. -2 minus, oops, I put the wrong thing, minus 2 times the quantity of 1 minus, and I'm sorry, that's supposed to say 7/5, not b. I'm going to put a parenthesis so it reads it as 7/5. Let's see if it reads it like that. And I get -1 and 1/5. So just because my answer looks weird doesn't mean that it's not the answer. Okay? All right, so saying this, sorry, I hit the microphone again. All right, so go ahead and give these two problems a try. Log in your answers to see if you got it right. All right, and then unpause this video when you're ready. All right, so let's take a look at our answers and power through working on these. So 1/2 times b would make 1/2 b. Half of 6 is the number 3. All right, equals 3 halves b minus 1. All right, I now need to move these. Who is smaller? Well, a half is smaller. All right, so we're going to subtract 1/2 from both sides. So we left with 3 equals. So if I have 1.5 minus a half, I should just have 1 left. I'm going to then add 1 to both sides. So B should have equaled 4. Okay, let's take a look at this other problem. All right, so we have 3x. So I can combine 15 minus 9. It's a math problem we've been doing forever. All right, so we have 3x. All right, 15 minus 9 is 6 equals 2x plus 4. So I distributed both sides of these. I'm going to now move my smaller x. So I'm going to subtract 2x from both sides. So x plus 6 equaled 4. I'm going to now subtract 6 from both sides. So x equaled -2. Did you get those right? All right, hopefully this video made some sense. Please rewatch and rework any problems as needed and be ready to practice these problems.